Hi everyone, welcome to week 4, day 1, video 1. So far, this is what we have done: trig functions, identities, polar coordinates, complex numbers, going to and from rectangular polar equations, and our next goal is to develop some tools which will be essential as you learn calculus later on. And so, um, to that end, our next topic is something called conic sections. And you had a brief encounter with conic sections in Math 103 under the topic of nonlinear equations, where you look at circles and ellipses, and then also a little bit of parabola. The 4 basic shapes we deal with are circles, parabolas, ellipses, and hyperbolas. So let's quickly go over what you know about some of these shapes. Okay, so let's start with circle. So circle, what is it? Given a point and a distance, the set of points, say a distance r distance from 0, 0. Okay, so this given point, the 0, 0, that's called the center of the circle. And this distance r is called the radius. So if you're given a point and a distance, then everything on this green line is going to be satisfying this condition of being at a distance of r from it. And to find the equation of this, if you take this point to be xy, and you have a right angle triangle, and you get this relation r square equals x square plus y square. If you write it the other way around, you get the equation of a circle, which is x square plus y square equals r square. Now, if the center is at a comma b and the radius is r, then this changes to x minus a squared plus y minus b squared equals r squared. So if you compare this equation, when you make a, b 0, both of them, then you get this back. And then the next, in the notes section, I asked you to fill out what you know about parabolas. So you can have four types of shapes. Yeah, 4 shapes. Let's say in general, you can have upward opening, downward opening, rightward opening, and leftward opening. Now, if this, some of them are familiar. For example, this is y equals x squared, and this is y equals negative x squared. This is x equals y squared, and this is x equals negative y squared. So this is a very basic shape. Now, we're going to learn about various other important terms in each of these shapes, but one that you already know is called the vertex. So the vertex is the lowest point or the highest point, the leftmost, rightmost point. But the more rigorous definition is it's sort of where the parabola changes the direction. For each of these, the vertex is at origin. Now, if the equation was, say, y equals x minus h squared plus k, then the vertex is at h comma k. So what this parabola would look like is hk right here, and when x is 0, y is k, so something like that. this point you can find, plug in x is 0, this is h squared plus k, 0 comma. But that is the vertex. So what this tells me is that just as in the circle case, when it's at 0, 0, the vertex, the equations are simple. Or when it's shifted, all I have to do is shift the vertex. Now, one of the tools that you learned about these vertex shifting examples is, let's say you have an equation x squared minus 2x. Now, just by looking at it, you can sort of guess that it's going to be a parabola because y doesn't have a square, so it's not a circle. X has a square, but there is this 2x. So what we use is completion of squares, meaning we make an observation that x minus 1 squared is x squared minus 2x plus 1. Now what this is missing is just this plus 1. So I'm going to add 1 and subtract 1, which is totally fine because then I'm just adding 0, which changes nothing. But it does help me to write this first 3 terms as a square, which means that this is now a parabola with vertex 1 comma 1. So this is y equals x squared, shift x to x minus 1, right? Y equals x minus 1 squared, and then shift down 1, y equals x minus 1 squared minus 1. So when you change x to x minus 1, that's a right shift. So you start with y equals x squared, you shift everything to the right, and then you shift everything down. So that this is now 1 comma minus 1, which is the new vertex. Then the last thing that you've seen in Math 103 is an equation of this form. Say x squared over 4 plus y squared over 9 equals 1. Equations of this form give us a shape called ellipse. We are going to go into much more details on day 3, but basically an ellipse is a circle, but it's flattened so that it's not symmetric anymore. And these points become 2, 0, negative 2, 0. This becomes 0, 3, and this is 0, negative 3. So these are unequal. So in general, x squared over a squared equals 1. And if a equals b, then it's a circle. So a circle is just a special form of an ellipse. Now, we've been calling these things conic sections. So where does that name come from? So here's the idea is we start with a cone, a two-sided, or let's say a double cone. And we look at what kind of sections can be formed, cross sections can be formed if I cut through this plane. So the first is, if I cut through with a horizontal plane on anywhere, it's horizontal. And if you think about it, this cross section, what is it going to look like? If it's horizontal, then it's going to be a circle. It's just going to be a perfect circle if I'm just cutting it parallel to the conic section. Now if I angled it a little bit, it would still be circular in shape, but it would no longer be symmetrical. If I angle these, so now I angle them, then they become oblong. They are no longer symmetric, and they give me an ellipse. And so then the cross section looks like that. So I started with flat and I got a circle. I changed the angle and I get ellipse. And now I go a little further and I increase the angle. If I go really vertical like that, You can see this shape is going to now not close, so it's going to look like a parabola, right? It's really going to go like that, and this point is going to be the vertex. And for the last one, I'm going to leave this as a bonus and see. So we horizontal sort of keep angling up. When this angled plane then crosses this particular edge and no longer closed figure, you start getting parabolas. And then the last shape, which we haven't yet talked about but is a hyperbola, is, can you think of what another way of cutting this cone have we not talked about? And whatever that way is going to give you the hyperbola, which is fine because you haven't seen hyperbolas before. But just think of an alternate way of cutting this that you can come up with. That's it for day one videos actually. Just a brief introduction. So if you want, you can move on to day two videos which cover parabolas.